But with that, I'm going to move us over to Jennifer, and I am going to pull my second computer up so I can tell you a little bit more about her. So Jennifer Jencks is from NOAA, and she's going to discuss one of the international efforts that is meant to encourage all types of mariners to help map the gaps in the bathymetric data coverage of our ocean floors. So I actually first learned about this project about 4 or 5 years ago when I moved over to NGA and learned that we had this really awesome crowdsourcing project. And having worked with Sophia, who leads up a big chunk of the federal crowdsourcing community, she authored and co-authored the federal crowdsourcing. I can't even remember the legislation component associated with it, but just was super excited about hearing that this was an activity that was happening, and loved that NOAA was really leaning forward to this. So Jennifer, I know we were talking a little bit about connection issues. Can you push your slides? Are you good?
I can. We are good to go.
So Jennifer, I'll let you take it away.
Okay, great. All right, let's go ahead and get this going. Okay, we're just gonna. Okay, can everybody see my screen? Hopefully. Yes, thumbs up. Thank you, Tom.
Yeah, looks all great.
Okay, perfect. All right, thank you. So yes, my name is Jennifer Jencks. I serve as the director of the International Hydrographic Organization's Data Center for Digital Bathymetry, or the DCDB, which we host here at NOAA's National Centers for Environmental Information out here in Boulder, Colorado. And we've been hosting this international bathymetric repository for over 30 years now. I also have on today John Cartwright, a colleague of mine who is the geospatial architect here at NCEI. That's my way of saying if you ask anything super duper technical, I'm going to totally put him on the spot and make him answer for you or for me. And so what I'm going to spend my couple of minutes discussing is highlighting this ongoing effort that's been underway for, again, around 5 years now, that's meant to encourage all sorts of mariners out there to help us map the gaps. And by gaps, what I am referring to is the extraordinary lack of data coverage that we have of our ocean floors. We're all used to the really pretty blue maps we see everywhere, but what's actually been mapped is shown here in rainbow colors. Less than 18% of the deep ocean floor, and only around half of the world's coastal waters have been mapped directly. So there are several ongoing and a few new national and international efforts that are determined to address this massive data deficiency issue by making comprehensive ocean mapping a priority for the coming decade. Now, one of these ongoing efforts was stood up back in 2014 when the IHO formally recognized that our traditional way of doing things, traditional survey boats alone just wasn't going to be enough to get the job done. And that to be successful, we really needed to start to get everyone to the table participating. And so they initiated a collaborative project meant to enable all mariners to collect crowdsourced bathymetry. So the IHO is defining CSB as the collection of depth measurements from vessels using standard navigation instruments while engaged in routine maritime operations. In every presentation I give, I have that sentence highlighted and underlined and bolded because, not surprising, we crafted this sentence with lawyers. Each word was picked to the bones, carries a lot of weight. But this is what sets it apart from marine scientific research, from hydrographic surveying, and sort of puts it in a legal class of its own. NOAA has been supporting this effort by building and hosting a data pipeline, which allows the public to contribute the data they collect to us, and then come in and discover and download the data through a web-based map viewer interface. So like most citizen science initiatives, part of the value here is that the data comes at little to no cost. This is a really big deal because surveying the seafloor is incredibly expensive. And no one here is arguing that crowdsourced bathymetry has the quality or the accuracy of professionally collected data, but it does play a role. It does fill gaps where data is scarce, such as the Arctic, such as around small island developing states. And it can be incredibly useful along coastlines where survey vessels may not visit often, if at all, but you might have a local fisherman that goes there every day. And while the data may or may not wind up on a nautical chart, it can and has been used in identifying uncharted features. It can also just help in verifying the charted information that's out there right now. But, and it's a really big but, we can only do this if we can get vessels to participate, to collect the data and donate that data to us while they're on passage. Oh, wrong way, wrong button. There we go. So how does this work? So who we work with is what we refer to as trusted nodes. So we have a growing number of these companies, these universities, these organizations that act as data coordinators and in some cases data aggregators. Rose Point Navigation was our original trusted node. They allow their customers to turn on their electronic charting system log file. They record their position, their depth, and their time. And then whenever that mariner updates the software or updates their chart catalog, then that log data is automatically transmitted to us. And then there's James Cook University down in Australia. We always highlight them as sort of our poster child for regional programs. They received $10,000 in government funding. They went out and purchased and distributed really cheap data loggers, around $200 a pop, to over 100 volunteer recreational boats. These boats are using their own echo sounders, their own GPS sensors, just while they're out doing their gallivanting, I guess, doing whatever it is you do out on the Great Barrier Reef, having a good time. So crowdsourced bathymetry, along with the other flavors of bathymetric data, single beam, multi-beam, products, all data that are bathymetric data that is archived at NOAA, and then also bathymetric data that we ingest the web services from other organizations are all discoverable through our IHO Data Center for Digital Bathymetry data viewer, and the URL is down there. Our viewer, just like all of the viewers at NCEI, uses standard web services to promote the discovery and the delivery of these data and associated metadata. The lines that you see here are generated to display the tracks of the ships where the data was collected. We don't do anything to the data after it comes into NOAA. We deliver the files as is back to the public. Now, while this file-based delivery does meet the needs of many of our customers, we do know it's not ideal. It puts the bulk of the work on our user community because any sort of data aggregation or data processing can only be done after they download the data. And today, our CSB data holdings are pretty small, especially if you compare it to our larger multi-beam bathymetry holdings. But they are growing every day, literally. We get thousands and thousands of files every day. And with these national and global mapping campaigns, such as Seabed 2030, picking up momentum, we know that now is the time for us to change, to improve the way we deliver, the way we showcase data to the community. So we are looking to create a scalable point store, a way that we could better handle and store these bathymetric data points or bathymetric data as a seamless collection of points. So along with providing the data the way that we do now, we could also provide a variety of services. And these services would allow the community to generate bathymetric grids of a given area. It would allow us to show the data density, which could actually help guide future data collection efforts. And it could provide statistics on the bathymetric measurements. So today, and really for the past year or so, we've been working with partners, we've been working with Amazon, we've been working with Esri to explore what point data discovery and visualization and access might actually look like. And so I always like to, in my slides, showcasing this quote from a colleague of mine, Tim Thornton. If we got 1% of all seagoing vessels to log their data, and on average they spent half their time at sea, then that's about 5 billion data points a day. And so if Tim is anywhere near right, crowdsourced bathymetry stands to become a significant contributor to our efforts to map the gaps. And we here at NOAA need to continue to do our part in making this data accessible to everyone. So thank you.
Awesome. Thank you so much, Jennifer. I really appreciate you sharing this today.
You bet.
Do we have any questions in the chat window? Because if not, I will probably end up asking questions. Okay, so my first question is, okay, so Lee Nicola asks the question, what about the hex organization of the data? So why did you all choose to use hexes as your common geometry?
To use lines as our common geometry?
Sorry about that, hexes. He says, I'm curious about the hex organization of the data, and that was in your previous slide.
Jen, if you want, I'll take that.
Yes, I'm gonna totally, this is John's pilot project, so absolutely, John.
So what you're seeing in this particular screenshot is a proof of concept that we're working on. So the data are stored in the point store as actually just a collection of points. And what we've done here is we've been experimenting with some of Esri's technology like the GeoEvent server and their spatial temporal big data store. And so in this case, what we're showing is just the point count. And in this particular application, as you zoom in and out, the size of the bins gets bigger or smaller. So it's not that the data are stored in hex bins, it's just a way of conveying the density of the data in this particular view. This is done dynamically as you zoom in and out.
Awesome, thank you. So this is an interesting question. 5 billion data points, question mark. What additional servers or resources would you need to handle that amount of data ingest? Does that feel like big data? Does that feel normal? How does that feel? 5 billion feels like a big number.
Would you like me to take that one too?
I'll let you go ahead and take this one. And I would say that this is why there is a very big reason I use that quote whenever I am talking about crowdsourced bathymetry to upper management, because I want them asking this question. I will say, especially since I deal with colleagues that are also trying to get their data sets, including passive acoustic sonar and water column sonar, those are massive volume data sets. So luckily on our side, these data volumes are very, very small. But yes, the actual number of data points are scary, which is why we are looking to go to the cloud, because we certainly don't have the infrastructure on site. But from there, I'll let John take that and expand.
Yeah, so I mean, the interesting thing about these data are that they, being points, it's not a lot of disk space, but it is a lot of records if you want to think about it that way. So it's very clear to us that even with our modest current holdings relative to what we might have, you know, we can't do this on premise. We don't have the hardware. We can't move fast enough to do this on premise, which is why we're looking at various approaches in the cloud. You know, we can continue to do the file-based data handling, even if it's 5 billion points, because that's some modest number of files. But if we really want to treat this as a continuous point store and treat each one of these point measurements, these bathymetric point measurements, as a record, then it's got to be in the cloud, and it's got to be something that can easily scale horizontally. You know, we've done some experiments looking at, for example, AWS Athena, and we've looked at some of Esri's technologies. We're looking at some others there. So we're still kind of experimenting with what's the best approach to handle this large number of records. Now, they're very narrow records if you think about, there's not a lot of attributes, but there are a lot of points. And we really like to get to the point where we can manage these as a seamless, continuous collection and not have to be treating them as separate files.
Thanks, John.
Oh, so there's so many questions in here. You guys are getting so many questions. Okay, I'm gonna ask one last question, and then I'm gonna have a few announcements. I'm sorry, I was going through the chat window. So one of the earlier questions was, has crowdsourced bathy, look at me being a slightly subject matter-ish like person, been used with freshwater recreational boats to track reservoir sedimentation? This is a super technical question. We totally get here sometimes. So thoughts on crowdsourced bathy being used for freshwater recreational boats to track reservoir sedimentation?
So the short answer is I don't know if it's been used for that. What I do know is that, and I'll make sure if this, since this is in the chat window, that I'll grab this later. So I chair the IHO crowdsourced bathymetry working group. And so where we are right now, we spent our first couple of years, I'm going to diverge and then come back. We've spent the first couple of years just trying to actually build a guidance document to help people collect and contribute this data. And we've sort of changed courses now, and we're really trying to document current use cases of the data that we know of, and then potential use cases of how this, how this data could be used. And so that is certainly one, since our group is mostly made up of hydrographers and some scientists, we certainly haven't gotten into looking at biological uses and things like that. So we need to start doing a better job of selling this data and to all of the different right use cases that could exist. So, I mean, I don't see why it couldn't be used for something like that, especially if it's in an area that's being frequented by all these boats that are collecting data. I mean, you're getting modern data to compare it to charts. The data is getting refreshed again and again. So it would be a very unique data set to be applied to those types of studies.
Awesome, thank you. So I'm going to encourage you, Jennifer, and to encourage your team of folks who are with you today. There's a couple more questions that are in the chat window. So as we kind of go through the next pieces, as you're able to answer questions, that'd be awesome. Thank you for taking this time. Really glad to have you join us. My last question before you close out is, hey, can we participate?
Absolutely, yes. So I do have our, no, that was extra slides in case you guys ask more questions. Let's see. So I do have, our email right here, Jennifer Jencks and John C. Cartwright. So please do reach out and we can certainly follow up and discuss, a bit more detail of what we're doing and who we're working with and how to get others to join up.